Let's take a look at our flight class and see how we might be able to use overloading to improve this class. Remember that we have the idea of our seats are 150 and we keep track of the number of passengers. And we've had that method we wrote much earlier in the course called add one passenger, where we just make sure that there's enough seats for one more passenger. If so, we add them. And if not, we go ahead and just handle that, which is just kind of report an error. Well, as we look ahead to maybe making this flight class a little bit more sophisticated, this idea of checking whether there's enough seats to add another passenger is something that we may have to reuse a lot. So why don't we go ahead and make that its own method. So we'll have a method called hasSeating. And inside of there, we'll just put that check in for is the number of passengers less than the number of seats available. And what we'll do is we'll update our add one passenger to go ahead and use that hasSeating method. So now as we're keeping track of what's going on with our flight, one of the things we might want to keep track of is the number of total checked bags. Now we're not going to limit the number of checked bags, but we are going to keep track of it. But something that we might want to limit is the idea of carry-ons. So what we're going to do is we're going to set the maximum number of carry-ons to whatever twice the number of seats are. Right? No one's supposed to have more than 2 carry-ons. And then we'll go ahead and keep track of that total carry-ons. And let's go ahead and add a method that just allows us to check to see that based on the number of carry-ons someone has, is there space for them. So all we'll do is just take how many total carry-ons we already have, how many carry-ons they're trying to bring on. As long as that doesn't exceed our maximum carry-ons, we'll go ahead and let them do it. Then, of course, we have all the other members we've seen previously. So I want to focus in on the idea of add one passenger, right? Because now that we're keeping track of things like total checked bags and carry-on, the idea of adding a passenger is going to be a bit more sophisticated. Let's go ahead and move this off to the side. Now we're still the same add one passenger we were just looking at. Nothing has changed there. Let's add a little bit more space to work here. So now if we think about overloading add one passenger, well, keeping track of checked bags is going to be important. So let's add an overload that accepts one integer, and that's the number of bags. And the logic inside there would be, well, we'll call our existing add one passenger, right, do that work, and then we'll add however many bags they've checked to the total checked bags. Now, one interesting thing about what we're doing here is that it's possible that we tried to add that passenger and there wasn't enough seats available. But in this case, we'd go ahead and increase the total checked bags. So what we can do is go ahead and wrap our code here so that we check the hasSeating before we do any of that other work. And this shows us a couple of things. First of all, notice that when we wanted to access the overload of add one passenger that took no arguments, there was no special syntax for that, right? It wasn't like with constructors where we had a special keyword. Here, we just called a method name with the right number of parameters. Also notice that when you're calling from one overloaded method to another overload of that same method, there's no rules about where it has to be. Remember, when we were talking about constructors, the chaining of constructors had to be the first line in the constructor. Here, it's just kind of a method call. You can call it from anywhere in the body of your method you need to. So now, remember that we also have the idea of a passenger class. Well, if we're writing a method to add one passenger, it's to probably accept an instance of the passenger class. Now, we're not going to do anything special here. All we're going to do is call the add one passenger that accepts an integer for checked bags. So we just call on our passenger get checked bags and pass that in. This shows us another interesting thing about method overloading. Our add one passenger that accept an integer number of bags, right? That was adding new functionality. That was functionality that we did not have before, the idea of keeping track of the total number of checked bags. But our add one passenger that accepts just a passenger instance, we certainly could have required someone who's using our flight class to simply call get checked bags themselves on passenger. But that's something we do very commonly, is that overloads sometimes are just used to add convenience. Right? So the one that accepts the passenger reference is a convenience overload. So someone didn't have to call get checked bags themselves. The one that accepts the integer number of bags actually adds functionality. So as we look at adding functionality, another thing we want to keep track of is this idea of carry-ons. Right? So we have an overload here now. It takes the number of checked bags and the number of carry-ons. So we'll check to see if we have seating. We'll go ahead and call the add one passenger that accepts an integer number of bags, and then we'll add the functionality to increase the total number of carry-ons. Now, one of the things we want to do here, of course, is that before we add the passenger, not only do we want to check for available seating, but we also want to make sure that we have space for their carry-on. Right? So again, this is an overload that's adding new functionality, validating that we have space for the carry-on, and then keeping track of that total number of carry-ons. And then we'll have another convenience overload here that accepts passenger reference and the number of carry-ons. And all that's going to do is call up to the implementation of add one passenger that accepts an integer number of bags and number of carry-ons. So our class has gotten a lot more sophisticated here now, right? The idea of adding a passenger can do a lot more things as opposed to just keeping count of number of passengers. We have to keep track of the number of checked bags, the number of carry-ons, and even limit how many carry-ons can get on to that flight. So let's focus in now on not just the implementation, but kind of just the signatures. Remember that the signature is the thing that determines which implementation of an overload gets called. So focusing in on just the signatures of these, let's go ahead and make some room here. So I've just pushed them all together. So these are the same exact methods we were just looking at. So we have just those 5 overloads of add one passenger. And let's see how it might get used in the program. So let's add some code here that goes ahead and creates a flight. Let's first create a passenger. And we're passing in 0 and 1 to the constructor. The reminder is the 0 is how many free checked bags I get. So in this case, they get 0, none. And how many bags they're checking, which is 1. Create another passenger that gets 0 free bags, but they are checking 2 bags. So we've got those all created. So now, if I call on flight add one passenger, well, this is the one with no parameters. So it's nice and easy to know which one that chooses. It just calls the implementation of add one passenger that accepts no parameters. I call add one passenger passing an integer. Okay, well, there's only one parameter here, so there are 2 possible overloads that can handle that, right? The one that accepts integer and the one that accepts passenger. But since we're passing an integer, it'll use the integer overload. Similarly, when I call the add one passenger passing in a reference to a passenger, it will call the overload that accepts a passenger. But let's go another step. Let's declare a local variable of type short called 3 bags that we set to 3. Now, when I call add one passenger passing in 3 bags as the first parameter, or short, and then 2 an integer as the second parameter. Well, there are 2 possible overloads here that accept 2 parameters, right? The one that accepts 2 integers, and one that accepts a passenger and an integer. Notice there is no overload that accepts the short. So how does the system decide which one to call? Well, it starts looking for the automatic conversions that it's able to perform. Remember back in Module 3, we talked about kind of these idea of automatic type conversions? Well, very similar rules are applied here in order to determine how to find the overload. So what happens is that since the system knows how to convert a short into an int, it will go ahead and call the overload that accepts an integer as the first parameter. And then finally, if we call add one passenger passing in a passenger and an integer, it of course calls the appropriate overload for that, the one that accepts a passenger and an integer.